Hello, and welcome to the Roads Density Tool webinar as part of the Grizzly Bear Tools package. My name is Cam McClelland. I'm a senior biologist with the Grizzly Bear Monitoring Project, and today I'm going to be going through how to run the Roads Density Tools. So first, let's just go over again, what are the grizzly bear tools? So we know that grizzly bears rely on their habitat to provide three essentials for life. The first is resources, such as food and water. The second is security, to prevent excessive rates of mortality. And the third is mobility, to allow dispersal into new territory and to maintain genetic diversity. So, spatial models were developed to predict all three of these attributes, with the goal to support and inform the long-term survival of grizzly bears and their habitats in Alberta. The goal of these tools is to preserve high-quality habitat and reduce mortality risk, to forecast the effects of development, and to compare the relative impact of multiple scenarios. So, just a little background on what it takes to run the Grizzly Bear Tools package. The Grizzly Bear Tools are a toolbox that can be used within the ArcGIS Pro program. And the tool set consists of base spatial data representing model predictor variables, geoprocessing scripts written in Python 3, and an ArcGIS Pro toolbox, which contains all the graphical user interfaces to run each script. Before we get into running the tools, I just wanted to go over the spatial layers within the tool. Layers within the tools are from 2021, and they're derived from the Alberta Biodiversity Monitoring Institute's Human Footprint Inventory, or HFI, that was released in 2023. HFI layers disturbance year lags by 2 to 3 years. Upon new releases of HFI updates, GBTools input layers are also updated to the latest landscape conditions available from any new release. Date of layers needs to be considered during interpretation. It is also important to note that canopy cover and percent conifer layers are from 2018. This is due to more up-to-date layers being too coarse, and currently we are searching for an alternative. Here is an overview of what tools we have at our disposal. So we have our road density tools, denning RSF tool, habitat states tool, and siteability tool. Today we're going to be going over our road density tools. So that's our add GBTools boundaries to map, calculate current road density, and calculate road density scenarios. There's one more road tool in here, which we won't be going into within these webinars, and that's our road reclamation tool. But this is actually covered within our road density tools, so we won't need to go into it. So why do we care about road density? Well, roads between collision and allowing access into grizzly bear habitat are the highest human contributor to grizzly bear mortality. And we have found that having a road density of greater than 0.6 kilometers by kilometer squared in core grizzly bear watershed units, or a road density greater than 0.75 kilometer by kilometer squared in secondary grizzly bear watershed units, has adverse consequences on grizzly bears. With the roads tool, we are able to determine road density in an area based on multiple road scenarios. By reclaiming, adding gates, or temporary closing roads, we can reduce road density on the landscape. It is important for running this tool that we run multiple plan scenarios to determine the best course of action when adding roads to the landscape. So I've already mentioned these grizzly bear watershed units, or GBWUs, but I'll just explain them because we run the tool based on these grizzly bear watershed units. So Alberta contains 7 grizzly bear management areas, or BMAs, and these bear population units, or BMAs, are further subdivided into grizzly bear watershed units. Grizzly bear watershed units are management units based on major watersheds subdivided along heights of land and along water courses to approximate the size of an adult female grizzly bear home range, which is approximately 700 kilometers squared. And we calculate our road densities per grizzly bear watershed unit. All right, in keeping with these GBWMUs, I'm just going to quickly go through a tool that allows us to add these and road layers to the map. So that's with the add GBTools boundaries to map. Here we have a very simple interface. We have our landscape conditions, which can't be changed, and we have another input to select an existing map. So let's just see how this is done. All right, now we're gonna just show you a way to add the roads layer and our grizzly bear watershed units to the map, which are specific for this tool, the roads tools. So we go to our add GBTools boundaries to map under our GBTools package under a GBTools Pro toolbox. Double click. We have two options here. We have landscape conditions, which remain as 2021, and we can't change these. And then we can select existing map. I'm going to select our roads map, which to add this to, and we're going to run it. That's complete, so we can close this. And now you see that we have several layers here. We have our trails layer for 2021, our roads layer for 2021, which can be used in any tool that requires road inputs. You can also grab these from base IP, which I show you with in the next section here when we're running our road density tool. We also have our grizzly bear watershed units split up into core habitat and secondary habitat, which when you add in your area of interest, you can see which grizzly bear watershed unit type your area of interest overlays. We also have our bear management units 1 through 7. We have a denning RSF boundary, which we'll go into later in the webinars. And then we have our GBTools boundary, which overlays the area that our GBTools encompass. And that's it. All right, now let's get back into going through our road density tool. So the road density tools are meant to work in a two-step process. First, we calculate the current state of road density within an area of interest. And second, we create a project scenario by adding or removing roads from the previous run and recalculate density for comparison. When calculating current road density, the road density tool calculates road densities for an area of interest specified within the tool, and we calculate road densities for each GBWU, or area of interest overlaps. And densities are generated by dividing the total length of roads within our area of within each grizzly bear watershed unit by the area of each grizzly bear watershed unit. Okay, let's get into the nitty gritty of the current road density tool, which is our first tool in the roads density suite of tools. So this is what what it looks like when you double click on the road density tool and pull it up. We have a GUI here, a graphical user interface, with 5 inputs, but really, as you'll see, there's really only 4 areas we can input information into. So this first input is our landscape conditions, and it reads 2021. This just shows what year the data the road densities are generated for, and this can't be changed. All right, our next input here, this is just where we're going to input our area of interest. So we have 2 options for it, really. We have the first one, which allows you to draw a polygon around your area of interest directly onto your current map. You can do this by using this pencil icon. We also have a option, so if you already have an area of interest generated, you can either drag and drop it in here or find it within your file folders using this file icon. So with these, you can just select one or the other, don't do both. And the road densities will be calculated for the area of interest specified. However, when we do put in the area of interest, you'll see that sometimes it calculates road density for a larger interest or area rather than your area of interest, and this is simply because we're calculating road density for the grizzly bear watershed units. Our next option here, this is where we're going to input our road layer. So you can either input the road layer that is provided within our GBTools, which can be found under base IP, access, and our access geo database. And I'll show you where that is in a second when we go through an example here. But you can also provide your own road layer in here if you have maybe a more accurate representation of the area, or if you just have your own roads layer that you wish to use. Finally, with our last input here, we're just going to enter the name of the folder where our results from running the tool will be stored and can be found. And these road density outputs are saved under our results folder, which is within our GBTools folder structure. And then they'll be under road density and then the folder name that you use. So if you, for example, were to enter your folder name as roads are us, the density outputs would be stored under results, road density, and roads are us. All right, let's see what this process looks like. We're just going to go through an example now. Let's calculate road density using the calculate current road density tool in GBTools. To do this, we're going to navigate to our GBTools is stored. We're going to open it up, navigate to our toolbox, GBTools Pro, open that up, and we're going to open up our calculate current road density tool. So once we open that up, you can see that we have 5 input options. The first is landscape conditions. This one can't be changed. It just denotes that the layers used in this tool from 2021. The next 2 inputs here are for our area of interest. So you can either draw your project area polygon on the active map, and this is if you don't already have an area of interest previously generated. Or the next option is if you do have an area of interest previously generated, you can drag and drop it in here. I'm just going to go over briefly how to draw your project area polygon on the active map. So first, we're going to click the pencil here. We're going to click polygons, and then we're just going to draw our polygon on the map. You can make it any size you want. Double click, and that just closes it. And that's going to be our area of interest if you wanted to do it that way. I don't want to do it that way, so I'm going to actually just remove this. And I already have my area of interest already loaded in here, as you can see. And I'm going to just drag and drop that into input your project area polygon. Next, we're going to input our road layer. So you can either use your own road layer that you want to calculate road density on, or you can input the road layer that we provide within Grizzly Bear Tools. I'm going to use that one. So I'm going to navigate to my Grizzly Bear Tools, navigate to base IP, navigate to access, navigate to our access geo database, and then there underneath that we have roads. And I'm just going to drag and drop that into input road layer. Lastly, I'm going to create an output folder name that will store our results. So I'm just going to call it something silly like roads are us. And those results will be stored over here. So under GBTools, under results, and under our road density folder. So let's run this and we can see what our results look like. All right, so it's complete. And now, if we look at our area of interest, you'll see, I'm just going to drag it to the top here so it overlays everything, that the results are much larger than our area of interest. This is because we generate road density for each grizzly bear watershed unit, which is what each of these, that our area of interest overlaps. And with that, we create 3 categories of road density. We have below 0.6 kilometer by kilometer squared, between 0.6 and 0.75 kilometer by kilometer squared, and greater than 0.75 kilometers by kilometer squared. And as you can see here, Most of our areas are below 0.6 kilometers by kilometers squared. Give me a sec. Except for we do have one that is in our middle category between 0.6 and 0.75 kilometer by kilometer squared, which might be a little bit more concerning. On top of that, we also generate a clipped roads layer that is clipped to each of the grizzly bear watershed units that overlap our area of interest. And that's about it. That's the calculate current road density tool. So we've gone through our calculate current road density tool. Now let's go through our calculate road density scenario tool. This tool allows users to add or remove roads using a previous calculate current road density output as reference. It is useful for planning road construction or restoration projects, and added or removed roads are used to recalculate road densities and compare these to current road conditions. This can only be run after a current road density output has been previously generated. All right, so let's get into this here. So our calculate road density scenario tool is located within our Grizzly Bear Tools Pro toolbox, and we have 5 inputs that we can input information into. Our first input here is where we're going to input the folder which holds a run from the calculate current road density tool. This folder is embedded in the following directory structure. So under our results folder, under road density, under the name of the folder that you named within your first current road density run, and then you must select the folder labeled current. Next, we have our reclamation section, and this is where we're going to input the roads that we're removing from our landscape, and we have 2 options for this. The first is to draw a polygon around the roads that you wish to remove using this pencil icon, and you can do that directly onto the map. Or if you already have a predefined polygon shape, you could input that in here. So just drag and drop it or search it with the folders tab here, and you just add that in here. So we just use one or the other of these inputs. Following this, we have our construct roads section. So again, we have the ability to draw roads directly onto the map using this pencil icon. Or if we already have a layer generated of roads that we want to construct, we'll just drag and drop that in here, or you can search it using this file tab again. Let's see what this process looks like and run through an example using the road density scenario tool. So now that we've calculated our current road density, we can now calculate some road density scenarios, which involve reclaiming roads or building roads on the landscape. To do this, we got to navigate to our GBTools, navigate to our GBTools Pro toolbox, and then double click on calculate road density. When this pops up, you see that we have 5 inputs. The top one is just where we have to navigate to our current road density folder that was generated when we calculated the current road density. So we open this up. I'm just going to show you where it is. So it's under your GBTools folder, under results, under road density, under the file that we named last time, which was roads are us, and current. Next, we have 2 options for removing reclaimed roads on the landscape. You can either draw a polygon directly onto the map using this pencil, or you can use remove roads using your own defined polygon. So if you have previously generated polygons surrounding those roads. I do not have that, so I'm just going to draw it directly on the map using the pencil polygons, and I'm going to remove these roads up here in this higher road density area. Double click to close it, and that's that. Next, we're going to come down here to these 2 inputs here, and these ones are for constructing new roads. And similar to the reclaimed roads, we have 2 options. We can either draw them directly onto the map using this top input, Or we can, if we already have a layer containing polylines that represent these roads that are going to be constructed, we can add that, drag and drop it in here. I do not have this, so I'm just going to construct new roads directly onto the landscape. So I'm going to click this pencil, click lines. And then I'm going to go a little crazy here so we can get some different results. I'm just going to draw some crazy roads all in here. If you want to finish one section of roads, you can double click and then start drawing some more roads. Draw one over here. Draw a bunch over here. That should be good. Okay, so we've got our removed roads for reclamation, and we've got our newly constructed roads in this scenario. So let's run it. Okay, we've ran it. Now we can close the tool. And let's first, this is our results. So we'll first close the scenario, and we can just take a look at our current road density. So we see, of course, we have lower density all over here and a higher density in this grizzly bear watershed unit up here. And now let's compare that to our road density scenario that we just generated. And as you can see, it's completely changed. So we've eliminated some roads in this top grizzly bear watershed unit, making it less dense and below our 0.6 kilometer by kilometer squared threshold. However, we've increased the road density in this middle watershed unit above our 0.75 kilometer by kilometer squared threshold. And that's not good. We've also increased the road density in this lower unit from below 0.6 kilometers by kilometer squared to between 0.6 and 0.75 kilometers by kilometer squared. And that's a little concerning. And so we can now see how adding and removing roads on the landscape affects the road density in grizzly bear watershed units and how this may affect grizzly bears going forward. Very important to all of our tools is how we interpret them. We're going to go through a little bit of the interpretation process in this next section. Over here, we have a map of our core and secondary access management zones. And just to reiterate, our goal is to have below 0.6 kilometer by kilometer squared road density within our core access management zones and below 0.75 kilometer by kilometer squared road density within our secondary access zone. This is concurrent with government policy within the grizzly bear recovery plan. And interestingly enough, and important to note, these densities are also used in BC. So most of Western Canada, because BC determined these exact same thresholds through an independent study. Looking at the current state of roads in Alberta, we can see that we are actually doing fairly well in this. We have only 3 grizzly bear watershed units over our 0.6 kilometer by kilometer squared road density threshold within our core access management areas. And that's very good. Our secondary access management areas are doing a little worse, though. We've got 10 grizzly bear watershed units over our 0.75 kilometer by kilometer squared threshold. When managing for roads, efforts need to be made to reduce road densities in areas over thresholds and to not push areas that are under these thresholds past them. In calculating current road densities alongside multiple scenarios involving road reclamation, closure, or gating, we can make strides to understand how developing new roads will affect the existing landscape. But what do we do when we run the tool, we run our scenarios, and we find that we are increasing road densities in a grizzly bear watershed unit above the accepted thresholds? So a few things that we can look at are, can roads be reclaimed, closed, or gated? Can a different access plan or road layout be used? Can sightlines be reduced using the siteability tool, which we will go over later in this webinar series? And how long will roads be on the landscape? And can this time be reduced? Continuing in this vein of roads and time, a few other things to consider. What is the longevity of the road? So is this going to be a forever road that stays on the landscape for 20 plus years? Or is this going to be a short-term road that might just be used for 3 years and then closed? Will the main use of the roads change over time? So will the road change hands between forestry, who may have been willing to close the road sooner, and then oil and gas may take over and add some wells in there. And the road use changes, and therefore the length of the road being on the landscape changes. If that happens, who is responsible for access management? And in this area, are there plans for other roads in the future? And can these roads be gated to be reused later on, or reclaimed to be reused later on as well? All right, let's compare how our road densities have changed from 2010 to 2021. On our leftmost map here, we have road densities in 2010. In our center map here, we have road densities in 2021. And for the most part, they remain relatively similar and stagnant. Maybe a couple road density or in our secondary accident management areas have been pushed beyond the thresholds, namely here and here. But for the most part, we remain very similar. When we look at it by just calculating the differences in road density across all Grizzly Bear watershed units from 2010 to 2021, we see that for the most part, we have reduced road density in most of our Grizzly Bear watershed units. So our blue and green colors represent a reduction in road density. Blue we've reduced our road density by more than 0.1 kilometer by kilometer squared. And green, we've reduced our road density between 0 and 0.1 kilometer by kilometer squared. And we can see that this is the case in most or in a lot of our grizzly bear watershed units. However, that being said, there are still a few watershed units where we have increased our road density, and namely in these yellow watershed units where we've increased our road density between 0 and 0.1 kilometer by kilometer squared. Um, and then even higher within our red watershed units where we've increased our road density by greater than 0.1 kilometer by kilometer squared. And these are the watershed units that we kind of need to watch out for. These are the ones where there's more roads going in than roads coming out. I think it's important to note that while we talk about gating, reclamation, road closure, uh, these do not entirely reduce risks that roads put into the landscape. Our best scenario is to never create roads, because once we do create roads, we can never fully limit access into these areas, whether that be by OHV or on foot. There is always the landscape, it will always be permanently changed, and there will always be increased access. So we need to really think about when we are putting new roads onto the landscape. A few other things to consider are, have you run the habitat states tool when we run the roads tool? And we can then look at and kind of drill down into how are these new roads affecting our RSF, our risk, and our habitat states outputs. Are these changing? Is it like further negative or positive? And how can adding new roads mitigate negative effects and decrease risk and improve habitat? So that can all be done within our habitat states tool set, and we will be going over that in another webinar. All right, well, thank you for listening to this webinar, and hopefully you can all now calculate road densities within your working areas. Um, I would finally like to say that if you're going through these tools, we want your feedback. So let us know how our tools are doing and whether you're going through them and you find one thing that you wish that they did more of, and we can potentially talk about implementing those into the tools. Thank you again.